Going to finish up the rest of your little twin here for your test. And I might go back and do number 1, but we're going to start on number 4. So the goal here, Tanner, is to yield the maximum profit. And there's a theorem that says profit is maximized when R prime of X equals C prime of X. It's a theorem that's really maximize profit when marginal revenue is equal to marginal cost. So you just got to figure out your two derivatives. What would R prime be? 5. How about C prime? 2000 X, that's right. I would just say 0.002. But good for you. Plus 1.3. And all you gotta do is set those two things equal. So 5 equals 2,000ths of X plus 1.3, and you can do a little subtraction, a little division. What are we gonna have? 3.7 on the left. Dividing by 2,000ths is like multiplying by 500. So it's going to be 1,500, 350, should be 1,850 when everything's said and done. Should be. So, that's the number of units that produced and sold that maximizes profit. And people do this stuff. I mean, MTD just doesn't make mowers. They have a production run. We're about to get interrupted here for something else. Be right back with you over there. I'm recording. It's okay.
Were these be right like that one? I couldn't really divide that. It's a little tight.
You're not going to say 0.005 over 2,000. You're going to say 5 over 2,000.
5 over.
Because a kilogram is 1,000 grams, so this is 5 grams compared to 2,000 grams. And, just go grab one of my calculators. 5 divided by 2,000. And then you press math what?
Isn't it math enter?
Enter. Yeah. 1/400. I know why you said 0.005. I know why you did that. But you only convert one. You don't convert both. So next up will be number 7. 7 is a natural log. Tanner, I don't guess you know how to find the derivative of a natural log, do you? Okay. There is a form, yeah. The derivative with respect to u of the natural log of u is 1 over u du. All you got to do is identify u. Look, I'm going to write it out above it. Natural log u. 3x squared. U is 3x squared. So u is 3x squared, and I'm going to have to find its derivative. What's the derivative of 3x squared? 6x. So I'm just going to write out what the rule says. It says throw u under a 1. That's what it says. So my y prime is going to be 1 over u, and u is 3x squared. And turn around and multiply it by what? du, which happened to be 6x. No, you're right. You're right. Yeah. Multiplication happens up high. So keep it up high. That's where multiplication happens. And then simplify. 6x over 3x squared. What's 6 over 3? 2. What's x over x squared? X. It's really simple. Once you figure out what the u deal is, it's pretty simple. Even you can do it once you know what u is. Next up is a logarithm. Yep, there's a form for everything. Derivative with respect to u of a log base A argument u. That's 1 over ulna. Is 1 over u natural logs of A du. Yeah, we figured it out. Tanner identified, if you're sitting at home, that that base was 10. And we just plug into that. And he also identified that u was 3x minus 1. And I'm sorry this is so jumbled up. Remember we did that problem earlier? It's all over this piece of paper. But du is going to be needed. What is du? It's 3. All right, so my y prime here is 1 over u. Tanner, what am I going to put there for that u? 3x minus 1. Wrap it. It's 2 terms. Natural log of the base. What was the base? 10. And then I multiply by the derivative of u, which is 3. That just goes up top. Can you do any simplification with that one? Always look for simplification. That's all I'm asking. Does 3 enter that 1 down low? No. You have to enter everything or nothing. It doesn't enter everything, so there's nothing you can do. So that's that thing's final answer. I told you, once you started figuring out u, it wouldn't be a problem. You seeing that now? Once you figure out what u is, it's not an issue. All right, here we have y equals 7 cosines of x. Now, the form on this one, if you're looking at the sheet, and I think you are looking at the sheet, the derivative with respect to u of a to the u. That's the one it is. Because we have a base and we have an exponent. Just like that form does. It has a base and an exponent. Is a to the u natural log a du. That's all it is. All you got to do is pick out a and u. What's a? 7. And u is cosine of x. You're going to have to figure out du, so you may as well do it now. What's the derivative of cosine? Negative sign. And then just plug in. So we've got our a to the u, which is the original function itself, 7 cosines of x. Then we have a natural log of a, and a was 7, times the negative sign of x. What you would probably see if I made this one multiple choice, I don't know if I will or not, but if it is multiple choice, the author of your book tends to put the negative sign out front. They just like it out front. For one, it's got a negative symbol. And they'd probably put the natural log of 7 out front, and then they'd put the 7 cosine of x, but it really doesn't matter. Like this is the correct answer. It really is. I don't think there's a way you can make that thing look pretty. Yeah, go ahead. You're good. You're good. I don't need your
Oh, no, already. I come back.
I don't need it. I don't really care how you write it, to be honest with you. Because I don't know how to make that thing look any prettier. I don't know what's prettier, sine, natural log, or 7 to cosine x. 11, it says you're not supposed to trust your key because I changed this problem before I hit the print button. So again, don't trust the key. 11 is actually the product rule. I've got so much black ink all over this thing, I'm going to get out a piece of white paper. When I look at 11, I see a 7x times an e to the negative 3x. It's the product of two things. You have to see that. Do you know the product rule, Tanner? Okay. So we write down the first thing, 7x, and then we take the derivative of the second thing. Now the second thing is going to take a rule. The derivative with respect to u of e to the u is e to the u du. You just got to pick out u. That's all you got to do. Negative 3x. So du is negative 3. I think you're actually learning something. Sounds like you are. So the derivative of this thing is e to the negative 3x times a what? No, not yet. I'm still taking the derivative of this guy. E to the negative 3x times what? Negative 3. Then what's the product rule say we do? What sign's in between them? Plus. So that's what this thing kind of looks like now. Now, if this one's multiple choice, which it stands a good chance of being, the author of your book is going to try and throw you off a little bit. Both pieces contain a 7e to the negative 3x. You see that? So they would pull it. It would get pulled. You would pull a 7e to the negative 3x. And what would be left in the first piece is this x times a negative 3, which is a negative 3x. And from the second piece, you'd have the understood 1 left over. So that would actually be how that one would appear. They would pull something if they could pull it. Hopefully that's not the part that's bugging me too much. All right, so it's 11. We got 12 up. 12 is inverse trig. We're asked to write an equation for the line tangent at the indicated point, which means we're going to find slope. And hopefully it won't be too bad. All right, this is arc secant. I'm going to make sure I write the rule down properly, because arc secant's one I have a tendency to mess up. Derivative with respect to u of the arc secant of u is 1 over the absolute value of u times the square root of u squared minus 1 du. We got kind of lucky on this one. It's just the arc secant of x. So u is x, right? So we look at our example. U is x, du is 1. Let's just plug an x in and be done with it. So y prime would be 1 over the absolute value of x times the square root of x squared minus 1 times that 1 for the derivative, which would be understood. Now, what we're going to do is we're going to plug in the 6, plug in x equals 6 to get slope. So all we got to do is plug a 6 into this thing. I do not feel like writing that out on a piece of paper. So down low, I've got the absolute value of 6, which is 6. I've got the square root of 6 squared, which is 36, minus 1, which is 35. That's what's down low. That's all being divided. 1 is being divided by that thing. And I find that my slope is about 0.028. I think they tell you to round to the nearest thousandth if necessary. So there's your slope, 0.028. We need a y value, don't we? All right, that's actually another little tricky part on this one. Y is going to be the arc secant of the x value, 6. Because if you have x, you get y by plugging it in. Your calculator does not have an arc secant button. It has an arc cosine button. Yeah, so you can actually do, it's not 1 over. It's the arc cosine of 1 over 6. the reciprocal. Because secant and cosine are reciprocals. So we just take the arc cosine of a sixth. That's about 1.403. And then we use point slope form. We have a y value, 1.403. Take away a slope, 0.028. Sorry, equal to a slope of 0.028. Times x minus the x value, which was 6. And if you can get that far, you can figure it out, right? So I'm not going to spend time on that. It wasn't that bad, was it? None of it really is. You just got intimidated. That's legit what happened. You got intimidated. I know that I remember Carolyn was asking for 14 and Julie was telling her it's not that hard. And Julie's right. You just have to remember a rule. When you had me for Algebra 2, I made you memorize this. X to the a over b is the bth root of x to the a. Which means you can rewrite that radical as something with an exponent. The root goes in the denominator, the power goes up high. So what would this thing look like as an exponent, in exponential form? X to the negative 3/7. And all you got to do is differentiate that thing. Where does the negative 3/7 go? Out front. What do we take away from negative 3/7? We take away 1, which means we're going to take away 7/7, which will be negative 10/7. Or you can just do it calculator. Doesn't matter. Now, if this x was complicated, we'd take its derivative, but it's not. So that is the answer, which looks to me like it's choice D. And look at that, we're almost done. You're trying to learn calculus? Next year, I think, is the last year I teach it. I think there's going to be no more kids who need it. And if they do, there'll only be 1 or 2. They'll just go to the team. At 15, what do we got here? We have a sine function with an odd-looking exponent. So we got sine function with an odd-looking exponent. This is actually the power rule function. It's like taking the derivative with respect to x of x to the n. Where's the n go? Out front. You take away 1, but then you also have to take the derivative of x. You have to take the derivative of whatever's inside. It looks ugly, but it is that rule. It is something with an exponent. That's all it is. So we're going to move that negative 1/4 out front. Negative 1/4 sine of x. We're going to decrease the exponent by 1. You take away 1 from a negative quarter, you know where you're at? Negative 5/4. Now what we have to do, maybe I should have done this in terms of u. The x value or the u value here is sine of x. What's the derivative of sine? Cosine. So we also have to include that derivative. If the argument of an exponent is complex, you have to take its derivative. Plain and simple. It's a chain rule. Then we have cosine of x. What we'll do is we'll rewrite this thing so that the exponents are positive. And we should be done with it. We've got a negative 1/4, so the whole thing is negative. There's a 1 up top. There's a 4 down low. The exponent on sine is negative. shift it down low, make the exponent positive, times cosine, multiplication happens up top. I believe that is answer choice C. Yeah. Isn't it? Any questions on that one?
Go back over the last number of fraction was.
Where I went from here to here?
Yeah.
I have a negative 1 over 4, so I made the whole thing negative. 1 up top, 4 down low, because it's literally 1 over 4. That guy had a negative exponent, so he gets down low. Exponent becomes positive. No, that rule.
Just multiply cosine by the.
Multiplied cosine by the 1, because multiplication opens up high.
Yeah.
Let's see, what's up with this one? Find the derivative with respect to the appropriate variable, and that is arc cosine. And there is no form for arc cosine. You can look at your sheet though, it tells you how to do it. The first thing you do is you do what's called a rewrite. You change it from arc cosine into arc sine. So we'd say y is pi over 2 minus, I need to check on this. That's not right. Y is 3.5 times pi over 2 minus arc sine of 3t. It actually won't matter. It will not matter, actually. There's a 3.5 in front of arc cosine. And arc cosine is pi over 2 minus arc sine. It won't actually matter. It's just a technicality. We're just going to put it back in. 3.5 pi is over 2 minus 3.5 arc sines of 3t. Wouldn't surprise me a bit if I taught it without doing that, because it doesn't matter. Because once we take the derivative of 3.5 pi over 2, what's going to happen to it? What's the derivative of a constant? Constants have no change. So the derivative or the slope is 0. So it actually doesn't matter where you put that 3.5 there or not. This piece becomes 0, but it has to stay here. It has to stay there. So minus 3.5 arc sines of 3t. So we're going to write down the formula here. We're going to leave that 3.5 out front. So the derivative with respect to u of the arc sine of u. I'm way too tired to promise I'll get this right, so I'm going to go look myself. It's 1 over square root of 1 minus u squared du. What you got to do is you got to pick out your u value. Now, do you understand why I kind of introduced this bracket? Because the 3.5 is not part of that thing I'm working with. It's just going to stay outside and float around for a while. And you can kind of see it down in the answer choices too. It's there. We got to pick out our u. Well, the u is the argument of the arc sine function, so what is u? Yeah, u is 3t. So u is 3t. That would make du 3. So 1 over square root of 1 minus a 3t, all of which is squared, times the derivative of 3, and that multiplication happens up high. I would think you'd probably be able to come up with the right answer by yourself now. I wouldn't do any more work. But on a multiple choice question, I wouldn't. It ain't B or D. Those are both positive answers. You just need to know what 3 times 3.5 is. That's exactly what it is. And you know, if you take your 3t and square it, what do you get? 9t squared. So yeah, it's choice A. It's the last one, Tanner. This is where you take the first and second derivative. It's called implicit differentiation. It starts off pretty easy. Then it gets a little bit rough because you have to use substitution techniques. The deal on these is whenever you take the derivative of y, include dy dx. I think that's really the gist of it. It's the only real difference. So the derivative of x to 3/5 is going to be 3/5 x to the negative 2/5, the subtraction of 1. The derivative of y to the 3/5 is going to be 3/5 y to the negative 2/5, but I took the derivative of y, so I have to state dy dx. dy dx. And that is equal to the derivative of a constant. And the derivative of a constant is always going to be 0. And now you solve it for dy dx. So I'm going to subtract that guy. 3/5 y to the negative 2/5 dy dx is equal to negative 3/5 x to the negative 2/5. And I'm going to do the division step. Divide by 3/5 y to the negative 2/5. Divide by 3/5 y to the negative 2/5. You good so far? Okay. The 3/5 will cancel. One up high, one down low. So that's gone. And the exponents can be swapped. A negative exponent up top, shift it down low. A negative exponent down low, shift it up high. Because you want to make them what? Positive. So we're going to have a negative symbol, because there's still a negative symbol. Y to the 2/5, x to the 2/5. So it's automatically throwing out choices B and D. Not that that matters, because I got to see the work. So now from here, what you have to do is you have to find the second derivative. It says find dy dx and find d squared y d squared x. So you got to take the derivative of this thing. That is the quotient rule. You remember the quotient rule? Let's do it with, this came from last year. I can't remember if I told you this or not. I got to write it out right. The derivative with respect to x of some function O over B is B O prime minus O B prime over B squared. Because it spells boob. It makes it easier to remember. So you can actually do most every one of those derivative rules and spell boob. I don't know if it's just a coincidence or what. Maybe Newton was a pervert. But almost every single derivative rule can be written to spell boob. But that's the deal. First guy derivative the second guy minus second guy derivative the first. Or sorry, the bottom. So anyways, we got to take the quotient rule on this thing. So we'll have x to the 2/5. That's the bottom piece. We have to take the derivative of this guy. And again, we're going to take the derivative of y. We have to say we did it. The derivative of that guy is going to be negative 2/5 y. We're going to take away 1 again. So we're going to go drop down to the negative 3/5 power. And we took the derivative of y, so we have to state that we took the derivative of y. We have to state dy dx. It gets really ugly. It's got lots of fractions in it. Then take away the product of the second guy, which is the negative y to the 2/5. times the derivative of the denominator, which is 2/5 x to the negative 3/5, all sitting over x to the 2/5 squared. If I was a kid, I'd be pretty intimidated by that thing. I won't lie, that thing would scare the crap out of me. That's fraction, 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 fraction. It's nothing but fractions. Here's what we can do. There's a dy dx. We know what dy dx is. We can plug it back in. Yeah, we plug back in that negative y to the 2/5 over x to the 2/5. And that will hopefully help us a little bit. It doesn't always. Sometimes it makes things more complex. It's going to look uglier. And I could see myself making sign mistakes on this problem. I go ahead and take care of something here. I see I have a negative times a negative over here, so I'm going to make that positive. And x to the 2/5 all squared is x to the 4/5. That is a very ugly looking thing. That's one of those you need more room on, or you got to write really small. I see a negative times a negative, so this top piece is going to become positive. And this is all one big multiplication string. Every last bit of it's one big multiplication string. So I'm going to rewrite it as a fraction. If it's got a positive exponent, it's going to stay up high. If it's got a negative exponent, I'm going to shift it down low. And you also have that 2/5. So 2 up high, 5 down low. I see an x to the 2/5 that's going to stay up high. I have a y to the negative 3/5 that I'm going to move to the bottom. I have a y to the 2/5. That almost sounds like a vape. I have a y to the 2/5 up high, and I have an x to the 2/5 down low. And normally I'd move on to the next one, but this thing is going to clean up a lot. There's an x to the 2/5 up high and down low. You see that? So they cancel. And this piece right here can be worked with. The deal with division of exponents is you subtract. So if you take away a negative 3/5 from a positive 2/5, you'd have 5/5, which is what? 1. So 1y. So that whole leading thing actually just reduced down into 2y over 5. So it actually got quite a bit simpler. Now we'll see if the second thing will reduce. I don't know that it will. We are going to have the 2/5 part. We're going to have a y to the 2/5 up top, and we're going to have an x to the 3/5 down low. That's all it looks like, isn't it? So plus 2y to the 2/5 over 5x to the 3/5. And that is all sitting over x to the 4/5, which doesn't look anything so far like anything we have written as an answer choice. So you add the fractions together. I think I made your class memorize this rule. A over B plus or minus C over D is AD plus or minus CB over BD. No, don't remember. It basically means give the other guy the piece he's missing. Like here we have 5 and 5x to the 3/5. This 2y needs x to the 3/5. This guy needs nothing because it already had x to the 3/5 down low and it's already got the 5 down low. So I'll give that 2y the x to the 3/5 power. I'll give the 2y to the 2/5 power nothing because it doesn't need it. And the unified denominator is 5x to the 3/5 power. And it's all sitting over x to the 4/5. You're almost done, actually. Where's division happen? And this is division. Shift that entire blasted thing right down there. The whole thing. Every last bit of it. Get shifted down there. 2y x to the 3/5 plus 2y to the 2/5 sitting over 5x to the 3/5 x to the 4/5. And hopefully I haven't made a mistake because, man, that's taking almost a whole sheet of paper. Those are like terms. Add the exponential space. 3 and 4 make 7. So 2y x to the 3/5 plus 2y to the 2/5 sitting over 5x to the 7/5 is hopefully my derivative. They've got something else added in there, don't they? They do. Those jerks. What have they done differently? The answer is C. I'd love to see if I can figure out the mistake that was made. Well, time to backtrack. That's what all this work is done for. So that you can find a mistake when you make them. Derivative of this guy is going to be negative 2/5 y to the negative 3/5 dy dx minus second guy, the top guy, negative y to the 2/5 times the derivative 2/5 x to the negative 3/5. The mistake is not there. I introduced the former derivative y to the 2/5 x to the 2/5. Change that. Negative times negative became positive. So the mistake hasn't been made yet. A rewrite was done. 2 over 5 x to the 2/5 One up high, one down low. Y to the 2/5 up high. Right there. It's right there. Well, when you move a negative exponent down low, what's supposed to happen? I didn't change it. Didn't change it. That was where the mistake was made. I'll go ahead and check the other one too, make sure I did it right. So yeah, that was where the mistake was made. Stinks, because now I gotta redo half a sheet of paper. Alright, so I should have 2 over 5, and I can actually make this one better now. Y to the 2/5, y to the 3/5. And I can reduce that thing a little bit more. 3 minus 2 is 1. So 2 over 5y to the 1/5 power, which is something you're starting to see in the answer document, right? Yeah, something we're starting to see. Plus 2y to the 2/5, 5x to the 3/5. And I'm going to do the same thing as I did before. I'm going to add the fractions together. So I'm going to give this 2 the x to the 3/5 power. This 2y to the 2/5, it's actually going to get this y to the 1/5 power, because that's the thing it doesn't contain. And the unified denominator is going to be 5y to the 1/5, x to the 3/5. And it's all sitting pretty over x to the 4/5. This is where we do that drop down step. All of that drops down. That's where division actually happens. So 2x to the 3/5 plus, we add exponents here, 2y to the 3/5. Feel like something's missing off that anyways. The bottom, we're going to have the 5y to the 1/5. And we're going to have that x to the 7/5. No, nothing's missing. It's just a simple little mistake on a sign change. So those problems are tedious and prone to it. And that's it except for number 1. You want me to do number 1? Sure. Think it helped you?
Because before now, I didn't even know what the year stuff was.
That's the easy part.
Yeah, I didn't. It's the easy part that helps out the rest of it.
Yeah. Well, I hope you at home who swore up and down you would watch this enjoyed the video. I certainly did not. Good day. Oh, and good luck Monday.